Hello everyone, trust you are doing good. In this video today I'll be working on hypocycloid. We have two types of cycloid. We have epicycloid and hypocycloid. I have done epicycloid before. You can take a look at that on this channel in the playlist on special coughs. Then we also have hypocycloid, but we need to understand what epicycloid and hypocycloid is saying. Like if you have a larger cycle this way, we have a larger cycle this way, and then we have a cycle that is rolling on the outside of this larger cycle, whose circumference are intersecting in this way. So as this cycle rolls on the outside of this larger cycle, the part that is going to be forming or that is going to form is what we call epicycloid. So the part that is going to form is what we call epicycloid. So I've done that in my previous video, so you can take a look at that. But the main purpose of this video is to work on hypocycloid. I'm going to be showing us a practical question now that we're going to be working on. Now for hypocycloid, we said is the part that is traced by a point on the circumference of a cycle as it rolls on the inside of a larger cycle. Don't forget, epicycloid rolls on the outside. Epicycloid is outside of a larger cycle. Why hypocycloid roll? If you have another cycle, maybe we have another cycle inside this larger cycle, okay, this directing cycle, and as it rolls, okay, in one complete revolution, the part that is going to be traced out or is going to form is what we call hypocycloid. So this is hypocycloid. So that is the part is going to form. The cycle will roll on the inner side of the larger cycle, as you can see this way. So let's look at a question now. Let's take a look at a question. The question we are going to be dealing with here says, okay, a cycle of diameter, okay, cycle of 50 mm diameter rolls on the inner side of the circumference of another cycle of 150 mm diameter. Okay, it's rolling on the inner side. Okay, you can see in this question now we are not told what we are to construct, whether it's epicycloid or hypocycloid, but by this question given to us, we will know that we have to draw hypocycloid, because for hypocycloid I said it rolls on the inside. The cycle rolls on the inside of a larger cycle. So the question says, trace the locus of a point on the circumference of the cycle of the rolling cycle for one complete revolution. So we are going to be drawing that for one complete revolution, and after we are done with that, the question further states that we should draw tangent and normal to the curve at 40 mm from the center of the directing cycle. But let's deal with this first part of the question. So I'm going to be drawing that. So the first thing we are going to be drawing now, we are going to be drawing the directing cycle, okay, the larger cycle. Okay, I will draw the larger cycle. So we draw this baseline. Okay, from this baseline now, take a point, any point. Okay, we can take this point. Let's call this point here O. All right, so we are told that the larger cycle, okay, it rolls on the inner side of the circumference of another cycle of diameter 150. So that is the larger cycle. The diameter is 150. So I'm going to measure using the radius to draw the cycle. That will be 75. So we have this 75. Okay, place on this point O. Okay, draw the circle. We may not draw the complete circle. may not necessarily draw the complete circle. So we have this. Okay, so we are going to be having another circle now, which will be rolling on the inside of this larger circle like we have here. So the next thing I'm going to do now, we are going to be picking the starting point for the circle, which is going to be rolling. Okay, we can start at any point on the circumference of this larger circle. Okay, so I usually like using 30 degree angle to represent the starting point of the circle. So we have this. We are told also that a circle of 50 mm diameter rolls. So this is the diameter of the smaller circle. So I'm going to be drawing that now. I will draw that now. That is 2.5 for the radius. 2.5 for the radius. So I'm going to place that at this point. Okay, mark this. So this will be the center of the rolling circle. So I'm going to draw that now. Place here. I'm going to draw the rolling circle now. So we have this, okay, as the center of the rolling circle. So I'm going to be dividing this circle now. I will divide this circle into 12. I will divide this circle into 12. Draw tangent. Draw a perpendicular line to this circle. Okay. From here. Okay. I'm using this inner part as my center reference. Okay. So if I have this now, I'll draw this. Okay. The circle has been divided into 4. So we divide the circle now into 12. You know how we do that. So with this radius of the circle, I'm going to place here, strike both sides this way, then place here, strike both sides, place here, strike at both sides, then place here, strike for both sides. Okay, so I'm going to number this way. Okay, if I call this 0, this is 1, the circle is rolling like this. This is 2, this is 3, this is 4, this is 5, this is 6, 7, 8, 9, 10, 11, and 12. So I will join them to divide the circle into 12. Join 4 and 10, passing through the center that way. I'm going to join 11 and 5, 11 and 5, passing through this center. Okay, then join 2 and 8, passing through the center this way. Then 1 and 7, also passing through the center this way. Okay, so we've neatly divided the circle into 12 equal parts. So the next thing I'm going to be doing now, I'm going to start from this center for the center of the directing circle. This is the center of the directing circle. Okay, so I will extend to 12, 0 and 12. That's where we have this arc here, as you can see that arc. So I will stretch to 1. I will stretch to 1. 1 and 11 will give us the same arc this way. I hope you can see this. 1 and 11 will produce the same arc this way, like we have here. Okay, then we have 2. Also we have 2 and 10, which will produce the same arc this way, as you can see here. 2 and 10 will give us the same arc this way. Okay, then we go also 3 and 9. 3 and 9, you can see 3 and 9 will produce the same center like this. Okay, then we are going to draw for the center of the circle. So this center of the circle, let's call that CO, center 0 for the circle. So for the center of the circle, just fix your compass this way, stretch to this CO, then we draw this. Okay, as you can see. All right, so we go now to to 4, now this 4 and 8 will be on the same arc. This 4 and 8 on the same arc this way. Okay, then we go to next one, 5 and 7 will be on the same arc like this, as you can see. Okay, then we have that. Then finally 6 we go this way. Okay, so this is 6. So the next thing I'm going to do now, I'm going to be dividing this circumference of the directing circle into 12 as well. So all I need to do is just to pick any of the division on the circumference of the rolling circle. So I'll pick this 5 and 6 point because they are equal. Don't forget, we divided them equally like that. So I'll place at 0, this 0 now. So we step off 12 times like that. That is 1. So I will do that. This is 2. I will do that until I get to 12. This is 3. This is 4 and 12. So let's number that just to be sure. So this is 1, this is 2, this is 3, 4, then 11 and 12. So the next thing I will do, from the center of the directing circle, I will just produce my line to touch from this center. Now draw to touch each of the division this way. Okay, then go to 2 from the center of the directing circle. Okay, then to 3, to 4, yes, for 11, and then draw for 12. Okay, so we have that all drawn out now. So the next thing I'm going to be doing now, I'm going to be getting my point for the hypocycloid. Okay, so I will take the radius of the rolling circle again, which is a small circle. Don't forget the radius is 2.5. You can measure that out, or you just pick it from this circle here. Okay, now let me just put in this is CO, which is the center of the rolling circle. Then this point is C1. Okay, C2. The circle is rolling 12 times. That is one complete revolution. So this is C4, C10, C11 and C12. So the next thing I'm going to be doing now, like I said, the radius of the rolling circle, this radius, I'm going to place as the center here. That is C1, center of the first circle. Okay, so I'm going to be marking the arc for 1, this arc here for 1. So take note of that point. You can take note of the point immediately. So the hypocycloid starts from 0. So you see this point now. So we have that. Okay, that is this 2 point there. Go to C2. C2 now. Mark for the second arc. Okay, the second arc, which is at this point here. Okay, you can see that. Then go to C3 and ensure that this compass radius do not shift. It has to be the radius of this rolling circle. Anything different from that, your work will be wrong. So go to C3. Okay, mark for the arc 3, so which is here. Okay, then let's go to C4. C4, this is for arc 4. Okay, this is for arc 4. Okay, you mark for arc 4. Okay, we'll go to C5. Always check that the radius is still intact. Okay, and if your compass is loose, you can tighten it up here. Then C5, strike for the 5, arc 5. So we have that here, we have that here, we have that here. Then C6, of course, it's going to be at the base here. Okay, it's going to be at the base here. Okay, yeah. Then C7, 6-7. Now to get 6-7, don't forget that 5 and 7 are on the same arc, so it's going to be here. Okay, this is C7. Then C8, C8 is what? 4 and 8 on the same arc, so this arc for 4 and 8 like this. So this is what I'm striking, so it is at this point. Okay, then C9, go to C9, then C9. For C9, strike 3 and 9 on the same arc, so this is the arc, just follow it that way. So it's here, so this is the point, C9. Okay, then go to C10, then locate the arc. This, okay, you can see that, so is this arc here. So this is for 10. Okay, then C11. So where is the arc? Here. Okay, so it's at this point here. Then finally 12, C12 here, of course, which is going to be at the edge here. You can see that. So we have this point. So we are going to take our curve now to smoothly join all of this curve, which is going to be producing our hypocycloid. So I'm going to join this part. I have this part join that way, and I have this part join as well. Okay, that way. Then I have also this part join this way. Then finally this part join this way. So this is my hypocycloid. The other part of the question says that we are to draw tangent and normal to the hypocycloid. So I'm going to be doing this in my next video. I'll be showing you how we draw tangent and normal to the hypocycloid. Thank you very much for staying tuned. God bless you.